This is January 2008 to AS2, question 1. A travelling wave passes through a medium. Figure 1.1 is a graph showing how the displacement of a particle at a certain point in the medium varies with time t. 4 measurements in the graph are lettered A, B, C and D. Figure 1.1 lists a number of quantities associated with the wave. Sum of all of these quantities are equal to measurements represented by the letters in figure 1.1. So the first one there is amplitude, and they're asking you which letter on the graph could give you amplitude. And so of course amplitude there must be this one, which is A. Then it says for frequency is the next one, and it says complete the table. If you think that the frequency is equal to C, write the letter C in the table. If you can't find any measurement in the graph equal to frequency, write the letter N. Now there's definitely no measurement on that graph equal to frequency. There's time in the axis, frequency is measured in hertz, so obviously it's not there. Right, the next one then is wavelength. Now despite the fact that it appears that there's a wavelength marked there, the axis is in time, in the units of time, so obviously that's not a wavelength, and we can't get wavelength from this graph, so the answer there is N. And then the last one then is time period, and this is what we can get from the graph. We can either get the time period from B, which is the time taken to make one complete wave, or it could be D multiplied by 2. So you could have B or D in here, they'd be happy enough. It then says, if you've used the letter N against any quantity, show carefully how that quantity can be obtained from the measurements A, B, C or D, together with any relevant definition or equation. Write your answers in the spaces below. Use the symbol V for the speed of the wave through the medium. You may not need to use all the spaces provided. So we have only two things there, frequency and wavelength, which you can't get. So the first one is frequency. The measurement which you could use is this B measurement, because that B measurement gives you time period. And so we're going to write down B there. How would you get it from that measurement? So B is equal to the time period, and therefore frequency is equal to 1 over B. The second one, which we haven't got here, is wavelength. And if you have a look at there, again, you can see B, you can see that you can get time period there, and therefore you can get frequency from the last question. And so we can use that to get wavelength. So lambda is the other one. The measurement that we require again is B. Frequency is 1 over B. And then we can use V is equal to lambda F. And lambda is equal to V over F. And therefore, since F is 1 over B, that's V times 1, or divided by 1 over B, then the answer is V times B. And that's how you get the wavelength. And you can't see any of that, so I'll just show you all that again. To get lambda, the measurement required is B. How to obtain it? F is equal to 1 over B, but V is equal to lambda F. So lambda rearranged is V over F, which is V over 1 over B, and divide by fraction, you multiply by it upside down, that gives you VB. We don't need to use a third space because we had only 2 quantities there that we weren't able to get. A quantity called phase difference is used to describe the relative positions of 2 or more waves. State the value of the phase difference between 2 waves which are exactly out of phase. Give the unit that you have quoted this value, in which you've quoted this value. So phase difference, if they're out of phase, is either 180 degrees, or you could use pi radians.